wrong list. That's good.
No, like I just like wrote it like I just like. You know, when your hand just like
The other way around.
was that one a sink or swim where it's just one thing wrong?
Probably sink or swim unless the thing you got wrong is like a semicolon. Said error free.
Mine's error free, but
it's got to be binary.
Oh yeah.
There will be other extra credit opportunities. So I figure just kind of pile up hard quizzes, then eventually people will be like desperate for like, okay, I need a free quiz. So they'll start going to these extra things.
So that brackets, like the square brackets, instead of putting it next to string, I put it next to args and it still runs. Is that wrong?
Since it still runs, I'll give you credit, but it technically is wrong. The only reason it's working is since you're not passing command line arguments into it, it's it's not getting the error because you're not actually passing command line arguments in. So.
Okay.
So you have it written like this.
Yeah, that's what I was like, because it's a list, so I put that brackets right behind.
Yeah, you have it written like this. This is actually a syntax that works in C++, so it technically still works in Java. This is saying I want to create a string array called args. Don't write it like that. Write it like this.
So what's the difference?
Well, if I've been teaching how you write variables is the type followed by the variable name. If you put it after this, which is the syntax that's still supported from C++, now you have a type followed by variable name followed by the rest of the type. It no longer follows the rules that I'm teaching, that you can have a consistent way of knowing how do I define variables. You define variables by saying, here's the variable type, here's the variable name. That makes sense? You might even be able to get away with putting nothing in there. Because now you're saying that I'm not expecting command line arguments, so don't try to give me any. Yeah.
Eclipse can actually auto-generate that first part for you.
Yeah, I know.
Oh.
Yeah, but don't have it. Yeah, when you create a new class in Eclipse, you can have it go ahead and say create the include the snippet of code for main. I would encourage you not to do that for a while until you get so bored having to write it that you appreciate what it's doing for you. This kind of falls into that category of, don't copy and paste stuff. If you find something on Google or something like that, type it. I mean, I want you to learn, and if you sometimes have to start with a working version of a program and then work backwards to see where you screwed up, that's okay. But type as much stuff by hand as you possibly can. That way you start recognizing your patterns of what things do you forget to do. Are you I forget to capitalize stuff. Curly braces are a problem. Semicolons are a problem. Everything's a problem. Whatever it is, you will improve by making mistakes and then having to go back and fix mistakes. And I promise you, you've probably already been there. You will get frustrated because you will spend 3 hours on something, and then finally you'll have somebody else look at it, and the problem will be just something stupid. Okay? But I bet you won't make that error again. Make sense? I mean, actually, I can give you an example of that. A common thing here. So I'll show it to you in real time here with our for loop stuff. I'll leave that there. Long time. Well, this is kind of a common mistake for loops that I've seen people make many times, and I made it once. This is when I was an undergrad in computer science, and I was in a parallel programming class, and we were writing a remember merge sort from last semester? Yeah. We were writing merge sort for multiple processors using a API called MPI, message passing interface. And it had this whole thing written. You're directing certain CPUs to do something. I was like, I don't know what's wrong with this. This should work. And every now and then, when you write a loop, you'll accidentally throw a little semicolon at the end of the loop here. All right, so notice when I put that semicolon there, it's no longer heard of I. because this loop began and ended right there. That's the end of the for loop statement. So the body of this guy, so let's say I just changed this to LOL, print LOL in there, so I'm not having to do scoping type stuff. Oh, when it tried to call main, it now has a problem with it. It did LOL one time because this is a single statement. That's a block statement that happens to only have one element in it. This is a single statement, but that for loop has zero statements associated with it because it ended right here. So my loop for my code back then, somewhere in there, I had a for loop with a semicolon at the end of it. And it didn't actually do what it was supposed to do, even though at a glance, it looked like it did exactly what it was supposed to do. All because you have this extra little semicolon right here at the end. Okay. And I either never make that mistake or very rarely make that mistake, or I quickly find that mistake now because it didn't, I mean, I probably spent 10 hours looking at that code. Changing stuff, like, why isn't this working? Like, just drive myself nuts. And then, I took it to the professor. He looked at it. He said, and it took him a while. And he gave it back to me and he said, this is what it was. And it's a stupid little mistake, right? And that was, one thing in about 400 lines of code. Because for multiple processors, it's a lot bigger program, the way MPI worked. But, yeah, I mean, the more things that you type yourself, the better off you'll be because you'll bump into problems like this. And I guarantee you're going to be frustrated. I guarantee you're going to spend a whole bunch of time doing something. Try not to treat it like a waste of time because you learned something during that frustrating time period. Make sense? Okay. So homework today was print all the numbers between 1 and 1 million that are easily divisible by 5. All right, so we have a for loop that's going to go from 1 all the way up to, let's see, that's 100,000, that's a million. So all the way up to a million, including a million. And instead of adding, I'm going to go ahead and start it off at 5. Each time through, I'll add 5 to it. So this will print out 5. Then 10, then 15, then 20, then 25, then 30. All right, so there's all of our numbers. If we want to see a little bit smaller list so we can actually scroll through it, there's up to 100. All right, so that would probably be the simplest way you could have written it. Now, if you wanted to actually test for something to be evenly divisible by something else, what was the operator we used last semester? What was that guy called? Modulo, the modulus operator. Okay, and it was the percent symbol in Python, right? It's also the percent symbol in Java. All right, so let's go ahead and modify this. I'm going to say, here, I'm just going to put that back to a million. I'm going to start off at 1. I'm only going to add 1 to it each time. So I'll literally go through all the values between 1 and a million. And each time through, I want to ask a question. I want to ask, is the current value I'm looking at evenly divisible by 5? Okay, and what does it mean for a value to be evenly divisible by 5? It means when I take that value and I divide it by 5, I get a remainder of 0, right? So I'll ask the question, if the current value when divided by 5 gives me a remainder of 0. Remember, the percentage symbol here will give me the remainder of the integer division I divided by 5. If I want the whole number portion of that, it's the slash. Java does not have an equivalent of the slash like Python did. Well, it does. It's actually a comment, but it doesn't have the give me the whole number division thing, so you don't get zeros. But we want the remainder here. So take I, divide it by 5, give me the remainder. If the remainder is equal to 0, then this guy must be evenly divisible by 5. Therefore, I want to print them out, but only if it met this criteria. that make sense? All right. So have the same values there. You want to shorten it, just go to 100 to test to see that it's giving you the right stuff. 100, 95, 90, 85, blah, 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 blah. All right. So not too bad, relatively small amount of code. Several of you should have found it pretty easy. Hopefully some of you ran into some rocky stuff with it and had some weird syntax issues and stuff like that and got through it. So start small and we'll build up from there. Questions about that assignment? Did you screw it up?
What?
Did you screw this one up?
No.
Are you lying?
No. It takes me 5 minutes.
5 minutes?
So
What if somebody else, what if it took them 3 hours and then you make them feel bad?
I'm sorry.
Like, this took me 5 minutes. I wasn't even awake.
My monitor on.
All right, so now what we want to do is we want to look at, so we've looked at how do we handle memory, so how do we write variables? We've looked at how do we ask questions, if statements. We've looked at loops. Okay, now we're going to look at how do we write functions. Okay, in object-oriented languages, they're typically called methods, but same thing. A reusable chunk of code, so let's give a definition to this guy. So we'll officially call it a method. Okay, but in parentheses here, I'll call it a function. Function is a fair synonym for this guy. The reason why some of these words get thrown around here is in a more historic language, we had things, we had functions and we had procedures. Now a function, this guy returned a value, where a procedure did not return a value. So if you were writing one of these guys and you explicitly did not want it to return a value, you would define it as a procedure. If you explicitly wanted it to return a value, you would write it as a function. There was a slightly different syntax between, well, really the difference was either the word func or the word proc, all right, for the keywords. That has kind of gone to the wayside in our object-oriented languages. Now we just call them methods, okay? And a method has a return type as part of it, and if you don't want to return something, the return type is void, all right? So in Java, as well as all that I can think of, object-oriented languages, the correct vocabulary term would be method, but if you think of it as functions, that's fine, it's the same thing. The syntax for this would be, so I'll go ahead and remove this because this isn't related to Java. That's more of a history thing, this function procedure stuff. So not something you need to know for in here, just kind of more of a trivia thing for the past. All right, so it's going to be return type, followed by method name, followed by opening parenthesis, followed by parameters, and these are comma delimited, followed by opening parenthesis, logic, closing parenthesis. All right, so what kind of value is my method going to return? What's the name of my method? What inputs does my method need? So if you don't want to, instead of parameters, you can call these guys inputs, synonyms for each other. And then opening curly brace, write your logic in there, closing curly brace. Now, if we're going to give a definition for a method or a function, anybody remember from last semester what these guys are? Or something close to our definition from last semester? That's definitely not the answer. Look at you. Huh?
Like, I know we did like the dice roller, so I think one of them was like, definition.
Just stare at them until they feel uncomfortable.
I feel like I know it. I just can't remember the exact.
When do you write a function? Let's start with that. So forget about like the memorized, definition before. In your own words, what's a function? When do we use those guys?
You write a function if you have a bunch of code that you want to reuse multiple times, so it's just easier to write it once and then you just refer back to that.
Okay, perfect. So I usually say it's a reusable chunk of code that we write once and can call multiple times. All right, so if we have something in our program that we need to do more than one time, okay, and maybe that's not the best rate. If it's like 1 or 2 lines and you only need to do it twice, maybe you don't write a whole method for it. But let's, as a general rule, we're saying if there's some logic that needs to occur more than once, it might be a good idea to go ahead and write a method that performs that logic, and then whenever you need to call that logic, you call that method. Make some sense? All right, so let's go ahead and let's see our example of this with a little modification to our homework. So for our homework, we were supposed to write code that went from 1 to 1,000,000, I have 100 in there right now, and printed out all the powers of 5 that were, in between there. So I'm going to go ahead, I'm going to write a function that does that same thing, and then we're going to keep enhancing our function a little bit, or our method a little bit, so you kind of see the purpose of these parameters. All right, so this guy's going to be printing a bunch of stuff to the screen, so I'm not actually returning anything. He's just printing stuff. Now, for right now, I'm going to always put the word static in front of my methods. Don't make me tell you why right now. I promise I'll give you the punchline soon, but for right now, always put static in front of it, okay? It's actually important, but it's not explainable to you right at this exact moment because we need some more context, all right? So we'll throw static in front just accidentally, all right? Now we have a return type, so our return type in this case is going to be void. Void says, I do not intend to return a value, because this function here is going to print a bunch of stuff to the screen, and big thing I might put here, and this is a common mistake for beginning programmers, printing stuff to the screen is different than returning something. So returning something would be like, you give it 2 numbers, it adds them together, and then it returns the result, as opposed to prints the result to the screen. If I'm going to return the result of 2 numbers being added together, my return type would be an int. If I'm just printing the result of 2 numbers being added together, I wouldn't return anything because I'm just printing it to the screen. So nobody else gets that value to use for some other purpose. All right. So in this case, I'm printing a bunch of stuff, so I'm not going to return anything. Therefore, my return type for my method syntax will be void. Okay. So there's my return type right there. All right, and I'm just going to call this guy print powers, and I'm going to have it take no parameters initially. So this guy requires 0 inputs. All right, and then I'll go ahead and take my code here, and I'll just paste it in there, and I'll leave it at 100 for right now, just because it's easier to read through. So here's print powers, returns nothing, requires no inputs. What does it do? It takes I on a voyage between 1 and 100, and any of those values that are evenly divisible by 5, it will print to the screen. It does not return those values, it just displays those values. Okay? Really, really important concept. Returning a value is different than displaying a value, because that is a problem that a lot of beginning programmers run into. Go ahead.
So when we started that new code with static, why did you not start with public like you did?
Because this is a function as opposed to a class.
Okay.
So we put public in front of classes. Later on, we actually will sometimes have public or private or protected in front of methods, but we don't have enough context to answer that right now.
It's technically private right now, right?
It's actually technically what's called package level security. If you put public in front of it, it's not broken. It still works, okay, but it's not required for what we're doing now. So any words for right now that say public or say static, kind of forget about them. Really, the only reason we even have to have public in front of our class up here is because it's actually the Java virtual machine that's calling upon this class, and it needs to be public in order to call main. for all of our other classes that we might write inside of the same package, which we'll talk about it, relatively soon. As long as we're in the same folder, they don't need to be public. Okay, and we'll talk a lot about public, private, and protected, so don't worry about that for right now. But this guy is a class, so he is a collection of some things. So we're going to talk about that in more detail. But from last semester, we talked about classes are a collection of fields, constructors, and methods. And right now we know how to create methods. Now it's a very recent skill. And we almost know how to create fields because fields are just variables that belong to a class. So it's going to be more of a positioning thing. And we'll see that in a little bit. Well, probably next class and the one after that. But in any case, for right now, you definitely have to put static in front of it. And there's a reason for that. That will be revealed at a later date. Okay, so right now I have the, there we go. I have a function named print powers that takes no inputs, that returns nothing. What does it do? It goes through all the values between 1 and 100, checks each one, and says, are you evenly divisible by 5? If yes, I'm going to print you to the screen. So what will the output of this program be right now? Okay, so the output is nothing. Okay, why is it nothing?
Because you don't have anything running inside of main.
All programs begin and end with main. So even though I wrote this ability, so I wrote a function that will print some powers. And the purpose of a function, it's a reusable chunk of code that we can write once and we can potentially call multiple times. I'm never actually calling it. I wrote the ability right here. But if I want to use it, I need to call the ability from somewhere. Right now, the only somewhere I have is main. So I'll go ahead and call upon this guy in here. So I'm going to say print powers, like that. Okay, now I'll go ahead and run this. Now the output will be 5, 10, 15, 20, so on and so forth. So there's all those values between 1 and 100 that are evenly divisible by 5. But now let's start taking advantage of the fact that this guy is a method. I can take some inputs. So maybe I say, I take in an integer and I say, what's the maximum value that I want to print these things between? So instead of going only up to 100, maybe I go up to max, whatever max was. And now I can pass in 100 if I want. So when I call print powers, that method requires me to pass it a single input that is an int. And what does it do with that input? It says I'm going to have a loop that goes from 1 to whatever input you gave me. In this case, I happen to give it a 100, so it'll print out the exact same stuff we just had. But if I gave this guy a 1000 instead, now it'll go all the way up to 1000. So on and so forth. That make sense?
Yeah.
Go ahead.
Just out of pure curiosity, if you put 1000.5 into it,
Like that?
Does it convert it to an int? Or
No, because the type of this guy is a double or a float, and that's not an int. These are incompatible types. I could do this. I could typecast it to an int, and that would convert it to the 1000 and then print it out if I really wanted to. All right, so now that takes me to just the maximum value. So I'm taking in one input. But what if I want to also have a minimum value? Instead of starting at 1, maybe I want to start at 30. So now I'll go ahead and I'll take in a second parameter. I can put it after this guy, I can put it before this guy, but whatever order you put them in here is the order you need to pass them. All right, so I'll say int min, comma, int max. So this guy needs to take in 2 values, the minimum value and the maximum value. So let's say that I want to go from 20 to 100. And then I'm going to change my 1 here to instead be min. So now I have a function that takes in 2 parameters, 2 integers, min and max, and I happen to use min to give me my starting point in my loop. I happen to use max to give you my ending point in the loop. And now this will go from 20 to 100. Go ahead.
Can you just explain again why we had to do that first part? So like
This guy right here?
part? Yeah.
Okay, so you just saw it run here, right? So if I take this out and I hit play, nothing's going to happen. Okay, and the reason for that, let's go ahead and put this on a slide. This is for main. All programs begin and end with main. So that means when we first run our program, and this is true of Java, this is true of C#, this is true of C++, this is true of C. In fact, that's where it came from, C. This is another one of those lineage things. So all programs begin and end with main. So when we first hit play here, when I hit play up here, the very first thing my program does is it jumps to line 1 of main and says, what is it that you would like me to do? So even though I've written all this extra crap down here, unless I call upon it from main or from someplace that main called, it'll never get called. So what does my program do? It follows the instructions that main tells it to do. Does that make some sense? Now, I'm going to amend that statement just a little bit once we get to Android programming, because when we get to Android programming, we won't actually see main. I promise it's there, but main is already written for us, and it does the extra magic stuff that gets your initial screen to pop up in an Android application. But it's there, somewhere under the hood, down and hidden in some folder somewhere. There will be a main, and that main will do some magic that you're not in charge of. So programs still begin and end with main with Android. You just won't actually see it. Okay? But when we're writing it like this, you will see it. If we're writing a C or a C++ program, you will see main. And that's where your program always starts. Now, main might then immediately call another function, which then calls another function, which then calls 5 other functions. So you might deviate off the tracks pretty quick, but your program still begins with main, and it ultimately will end with main. So when we hit this closing curly brace of main, our program's over. That make sense? Did that answer? Was that what you were looking for? To clarify? Yeah. So it's a good point of thumb when somebody asks you, "What does this program do?" Always go to main first and say what instructions are given in main. And if there's nothing in there, it doesn't matter how much other fluff we have. The answer will always be, this program does nothing. Okay. So if I want this guy to do something, I need to actually call upon my function. And this guy, in this case, is, I think I passed it, 20 and 100 or something like that. And that'll print out all the values between 20 and 100. Then I can call that same function a second time. And maybe this time I say print out the values between 200 and 400. So I'm actually calling upon my function twice now. The first time I'm giving it a minimum of 20 and a maximum of 100. The second time I'm giving it a minimum of 200 and a maximum of 400. So it's going to get this, it's going to perform this logic 2 separate times with 2 separate calls to that logic. All right, so I'll go ahead and hit print, and the second time it went all the way up to 400, but if I scroll up, you'll see here's the 200, that's the start of my second call, but here's the end of my first call where it just went to 100. Make sense? All right, so here's a reusable chunk of code that we write once and can call multiple times. Now, we might want to take this a step further and say, well, maybe I take a third parameter. Maybe I take a parameter that is the value that I wanted to check to see if it's divisible by. Instead of hard coding 5, maybe I take in an int divis or something like that. So instead of a 5 here, I pass it divis. So maybe from 20 to 100, I want to say I'm interested in the values that are divisible by 3. And maybe from 200 to 400, I say I want the values that are divisible by 7. That makes sense? You see how we keep making this more and more generic? Now, that doesn't mean always make your functions ultimately generic. If you are doing something that's always about being divisible by 5, you don't have to arbitrarily make somebody pass in extra parameters. But understand that the purpose of having parameters is that you can have a function that can operate a little bit differently depending on the inputs you provide it. Just like your TV works differently when you have the direct TV box hooked up to it versus having the Xbox hooked up to it. Depending on what your input is, different stuff shows up on the screen. Make sense? That's a pretty good example. Yeah.
Does it need to be like the same type?
Oh, it's a good question. It does not. So let's just throw this is gonna be extremely random, but we're gonna throw in an extra value here, string. We're gonna call this guy the suffix. All right. So after we print out our value, we're gonna go ahead and add to it whatever suffix was. All right. So up here we'll print out maybe a suffix of LOL, and this guy will be a suffix of woot. So her question was, do all the parameters need to be the same type? The answer is no. So in this case, I'm taking in 4 inputs. 3 of them are integers. 1 of them is a string. And what am I doing with that string? I'm just tossing it onto the end of all of my numbers, just because. So I'm going to have a whole bunch of number followed by LOL and a whole bunch of number followed by woot when I write this, and it's going to be ones that are evenly divisible by 3 and evenly divisible by 7. So here's the 7s here, 301, 308, 315, and then here's the 3s here, the 75, LOL, blah, blah, blah. Go ahead.
For the int min max and divis, do you need the int in front of each one, or can you do int min?
You do need the int in front of each one. Yep. So this is type followed by variable name. It does not matter what you call the variable name here, as long as whatever you name it here, that's what you name it down here. Okay, so you probably want to name your variable name something meaningful so that whoever's up here, when they go and call it, they know, okay, what am I supposed to pass you? I'm supposed to pass you the minimum value, followed by the maximum value, followed by the divisible value, followed by this random thing, what was this guy smoking? Okay. Now, one thing you might do as a good, especially when you start getting into functions like this that have lots of parameters, and especially in a larger project where you might not be the only one programming it, you might put some comments before this. So you can make a single line comment with 2 front slashes. So, you can type in some stuff, but then the very next line is not a comment. You can also put in a multi-line comment by putting front slash asterisk. And then when you press enter, you notice that Eclipse goes ahead and finishes your comment for you. So this allows me to write multiple things here. So what I can do is I can say maybe min smallest value to start with, max value to end with, divis what value, let's see, prints out only if evenly divisible by this value, something like that. It's just notes. We're just giving ourselves notes. And then suffix, okay, whatever. Entertainment purposes or something like that, okay, because it doesn't really have a whole lot to do with our logic, just showing us that we can have different types passed in here. Okay, and then maybe the first line of this, you do something like prints out all values evenly, let's see, all values between min and max that are evenly divisible by divis. Something like that. So what does this function do? What do the parameters mean? Something like that. Now, you don't always have to comment every single function you write. Some of them are kind of self-explanatory. But as the function gets more and more complex, you really might want to comment it. It might be a good idea to get into the practice of throwing comments before functions. if for no other reason than when you go back and reference this code later on, it's a quick reminder of what you were trying to do there. Make sense? You probably won't see me throw a lot of comments and stuff in class because they're quick little throwaway functions, but do as I say, not as I do, I guess. Something along those lines. I'm not going to grade you on comments, but it should be something you do get into the habit of doing. One thing that does happen in some programming classes that I don't agree with is this kind of falls into a similar category of like when somebody says, write a paper that answers some question. And then you say, well, how long does the paper need to be? Well, the real answer is it needs to be long enough, right? How often have you been given a homework to do a 5-page paper on something where you can only find 3 pages worth of stuff? Okay, and now you're just throwing fluff in there to stretch it out, right? Okay, similarly, how long should a comment be? It should be long enough, anywhere between 0 and, if you're doing something really crazy, you might have 2 or 3 paragraphs of comments there. It's like, look, read before you change or something. It might be something crazy we're doing down here. And then that becomes important. But there isn't a minimum or maximum number of characters you should have in comments, because one thing you can run into is you can get, what would it be? Comment diarrhea, I think would be the best way of putting it. And also before lunch, it's appropriate. But if you start commenting every single line of your program, then your program kind of becomes unreadable, right? Because now you can't even see can't see the code from the comments. So comment where it makes sense. Don't just throw a comment in front of something or after something because you think it should be commented or you were told, oh, you have to comment every line. That makes some sense? Like we wouldn't go here and say, right before this guy, I is our counter. Or after this guy, increment I by 1. All of a sudden you have little notations next to everything and it just starts becoming crazy. Okay? Go ahead.
Question, so if it's not return a value, so then if you run it in the main, for example, like you need that to spit out the values in order to run another function, how is that going to work?
You mean if you had another function that relied on this guy?
Yeah.
Then you probably would have it return a value.
Oh, okay.
So what she's saying is, let's say I write another function. So let's go ahead and write a second function here. So we're going to throw static in front just because, right? That's what we do. And maybe we call this guy, maybe this guy returns an int. Maybe it's called add1. Actually, well, one we called add num. And this guy's going to take in an int value and an int num. And what we're going to do is we're going to return whatever the value was plus the number you said to add. Okay? So if we're calling this directly, we would say something like add num, and maybe we pass it a 17 as the value, and maybe we want them to add 4 to that. Okay? So if this is the case, this guy's going to spit out a 21, but I'm not doing anything with that 21 right now. So my code's going to spit out the exact same thing it did before, because this 21 happens, but it just boils down to this. What I have highlighted there boils down to a 21. I'm not doing anything with it. I could store it in a variable and then use it for something else later. I can print it directly. I can say system.out.println. So I can say I want to print out whatever this guy boils down to. And even though that guy looks like it's doing something crazy, ultimately it boils down to an int. All right. What int? Well, I'm passing 17 in here for value. I'm passing 4 in here for num. What does this guy do? It takes value, adds to it num, and returns the answer as an int. That's what that code does. Okay, so this will now print out that 21 as the last thing. So there's my 21. Okay, well now what she was asking is, what if I said, well, I want to go ahead and I want to add to the result of calling print powers with a 200, a 400, a 7, and a woot. So here's my first parameter here, print powers. It's expecting an integer. Okay, so add nums requires 2 inputs, 2 ints. The first input should be a value. And what am I passing in for that first input? I'm passing in what I have highlighted here. The result of print powers, passing it a 200, a 400, a 7, and the word woot. Now, what does print powers return? Void. Is void the same thing as an int? It's not. This is why add nums is upset right now. It says the method add num int in the type driver is not applicable for the arguments void int. I'm not passing it appropriate inputs. That makes sense? So if I want to be able to put a function in here, you know, maybe I go ahead and I say static int pick a number or something like that, and we're going to be super random about this and just say this guy always returns a 7. Okay, that's what the guy does. Okay. Probably wouldn't throw that in a function. You might want to randomize a value in here, and I'll show you how to do that here in a few minutes. But this guy's called pick a number. He just returns a 7. Very guessable number. All right. Well, now I can go in here, and instead of calling print powers, I can call pick a number as my first parameter here. And it's okay with this one because add num is expecting a first parameter of type int. What does pick a number boil down to? It boils down to an int. Make sense? So this code right here, what I have highlighted, will ultimately become a 7. So what am I passing into add num? I'm passing into 7, and I'm passing into 4, and that's going to give me an 11. That's going to get returned there. And what am I doing with the value that's getting returned? I'm printing it. So this guy right here that I have highlighted will be a 7. Given that it's a 7, this guy right here will boil down to an 11. What am I doing with that 11? I'm printing it. So there's my 11 down here. Go ahead.
That integer, is it just only one type? Like, you see how like you
Which one?
Static. Okay, static integer add num, and
Yep.
you have integer the value. So then, is it only take integer for that specific function? Can you take like
for which one? Which int are we talking about? This one?
Yeah. So you have integer value. Can you take like integer value and then string something?
No, because this guy takes 2 parameters, and they both have to be ints.
Okay.
If you wanted to take in a string, you need to change this to take in a string.
So then there's no like. So.
You write the function to take in the inputs that you need it to take in. Okay. So if you have a function that takes 2 integers like this guy, you have to pass it 2 integers. Can't pass it 1 integer, can't pass it 4 integers, can't pass it some strings. It's got to be exactly that.
Are you referring to the method type instead?
This guy here?
Like, so if you have
like
an integer
the print
there,
power, like the print power one, like is there any way that you can change that into that's something that can return a value?
Well, you can. I mean, the way we currently have it written, it prints a bunch of stuff. But I mean, if you want this guy to return let's say we wanted to return a Boolean, you know, right now it's not going to be happy because it's saying this guy doesn't return a value. You know, so we can say we want to add a return statement. So down here at the very bottom, we can always just say, you know, return false or something. So now I've changed it to return a Boolean. Now I have to return a Boolean somewhere. So now I returned a Boolean. So you would only claim you're going to return a value here if your function does something that indeed needs to return something.
Great question.
Yeah.
In that print power, instead of return a Boolean, can you return an integer?
Return anything.
Okay.
Anything that's a type. So if I want to say return an int, then I'm going to have, you know, some value it's going to return. Maybe I want to have int count is equal to 0. And every single time I find a value that evenly divides the thing, maybe I say count is equal to count plus 1. And then down here, I actually return count. So now print powers will go through and it will print out all the numbers between min and max that are evenly divisible by divis. And then it will ultimately return the number of values it printed out. So that might be a reasonable thing to do for that kind of function. I'm going to print a whole bunch of stuff out, and then I'm going to let you know how many things I actually printed out in case that number is meaningful to you. Does that make sense? So now I have that same function that does the same thing as it did before, but now it does a little bit more so that it ultimately will return a value. But you can't claim to return an int and then not return an int. It's not going to be happy with this. If you advertise to Java that you're going to return a value, Java requires that you return that value. So this guy's here is going to say, this method must return a result of type int because I said it would. That make sense? Okay, but as it's written right now, print powers does a whole bunch of printing stuff, but it also then returns an integer. What's the integer represent? The number of things that was actually printed out.
So does that mean if you put that print power into the add a number, it should work?
Now it'll work.
Okay.
Yep. So if I take this guy here, because now this dude boils down to a number. So instead of calling pick a number, if I pass in print power between 20 and 100 divisible by 3, this is going to add up all the numbers between 20 and 100 that are divisible by 3. This will boil down to that value, and we'll add to that a 4. So how many values between 20 and 100 are divisible by 3? So we start with 21, 24, so on and so forth. So 21, 24, 27, 29, so 4 per 10. Huh? 30? All right, so we should add a 4 to it, which should give us the 34 then. You sure it's only 30?
It's like 21, 24, 27, 30. It's like 20.
Yeah, I added wrong. That's what you're saying. I couldn't add 3 to 27. I'm old. All right, so in any case, whatever the total number is there, there's our 31, which was a, so subtract 4 from it, that's 27, right? There's only, yeah, I guess that does make sense. So there's 27 values that would have printed out between 20 and 100 that are divisible by 3. So this guy boiled down to a 27. Then we passed that into add num. So the first parameter of add nums was 27. That came in as value. And then num is the second parameter. So we passed in a 4 for num, and we returned whatever value held and added to it whatever num was. And that's the value we returned. Make some sense? Which part doesn't make sense?
Why does it print out LOL?
Because that's what print powers does. Print powers says, I'm going to print all the values between 20 and 100 that are divisible by 3, and I'm going to stick an LOL at the end of it. So before print powers, we come down here to print powers. Before this guy ever returns a value, it does all this stuff. And one of the things it does is prints a bunch of crap to the screen. It prints a number that was evenly divisible by, in this case, 3, followed by that LOL that I passed in. So print power still does its thing. It still does all of its logic. Then ultimately it returned a value that I then used with add num, and that's that last thing.
So why is it pick 27?
Because that happened, because I counted here. I started to count off at 0. I went through all the values between min and max, checking to see if it was evenly divisible by divis, whatever I passed in for those 3 values. And if I got inside of this if statement, if I found a value that in this case was evenly divisible by 3, I added 1 to my count. So I counted the number of numbers that were evenly divisible by divis. And then I ultimately returned that count.
So from what you're saying is that print power prints out LOL 27 times, and it's
also add 4 to it, so it's turned out to be 30.
Well, print power prints out a number followed by LOL, in this case 27 times, and then it returns a 27. Add num takes two values and adds them together. What are the two values I gave it? I gave it a 27 from that guy and a 4. Does that make sense? So I'm kind of putting all these things together. So when you're reading code, this goes back to, I think we had a slide talking about variable resolution, what a value boils down to. So when we look at something like this print powers, yeah, it's a function and we're passing it all these inputs. But ultimately, that guy boils down to whatever his return type is, which in this case is an int. So it doesn't matter how complex this looks like. At the end of the day, that might do a bunch of stuff. In this case, it printed a bunch of things to the screen. But at the end of the day, that guy's going to become a single number. Make sense? And that's what add num requires, is a number. Okay, so it's very important that when you're looking at code, you consider, what does this resolve to? What kind of value, or sometimes I refer to what kind of animal am I dealing with here? Okay. All right, so questions about any of this method, function, stuff, thing, majigs?
Post it on Slack later.
No. How about I post it on Slack now? So functions thingy jig J? Yeah, that looks right. We literally have a crazy person teaching our class. What's this? Yeah, well, I don't know. Depends on your learning style, maybe. I also can't see my screen.
Oh, really?
Yeah, I really like because I started wearing contacts about a year ago, but I wore trifocals beforehand. And I'm kind of done like programming day to day, like professionally, so I don't care anymore. But like I could barely see what's on my screen here. I might as well just have the thing turned off. But it's great for golf. Oh my gosh, I can see the ball land because my distance vision is so much better. Oh, it's great. Yeah, so I'll be on the tour eventually, maybe.
Is the course right now?
We'll see. I mean, I've been able to play this last several days, but they might let us take the cart onto the grass today. We'll see. It's been cart path only, which I don't mind because I mean I like the extra walk. I just have trouble walking the entire course, but I'll park farther away and just walk a little extra or something like that. So I don't mind that, but we'll see what they allow. Okay, so I put that up on Slack so I could delete all this stuff now.
Yes.
See, that's always my favorite thing to do in programming classes when you have all this like tough logic that you like spent just hours and hours and hours on in your homework, and I come into class and I solve it and then I immediately delete it, and it's like, that's gold. Like, why are you doing that? You put that into a file and you save it. And then 4 years from now you're going and copying the code and you're like, what was this from? Because you never commented it. You're your own worst enemy. I'm definitely my own worst enemy. It's terrible. Let's see, what are we talking about next? Probably strings. So we know how to, we've covered how do human beings solve problems, right? Memory, asking questions, repetition. So already we can solve a whole bunch of like maybe mathy type problems with Java. So when we were almost completely caught up to where we were with Python. We know how to write functions. We're kind of missing kind of the list equivalent right now. And then we did a lot of stuff with strings. So let's kind of fill in those couple of blanks. So let's talk about strings first. I like to think of Java as being a string-based language. So I'm just going to write that on the slide. So Java is a string-based language. And what I mean by that is if we have something in the format of a string, we can easily get it into other formats. All right. So you might say that in Java, strings are very malleable. Java has a lot of tools for working with strings that it is in your best interest to, if you need to come up with a generic format for something, to store it in a string because you can pull the value out of a string very easily. Okay, we're going to see that over our next several homework assignments. All right, so we want to talk about abilities of strings. But first, let's talk about what is a string. A string is a collection of char primitive types surrounded by double quotes. For example, hello is a string. Banging on the keyboard a bunch of times, followed by some spaces, followed by some numbers, followed by, I don't know, some other random stuff. Also a string. Okay, so it's a collection of char primitive types surrounded by double quotes. What's a char primitive type? Did I spell something by accident? No. You always got to be careful. Sometimes you accidentally write bad words when you just bang on the keyboard.
Could be a bad word.
Yeah, I guess that's true. I think I might have maybe told you this last semester. There was I mean, it was a while ago. It must have been 10 years ago or something like that. I was in a class, did something pretty similar, and it was the F word. And it was up there for like, we were on the same slide for like 25 minutes, just sitting there in the middle of the slide. What makes it worse is like, nobody brought it to my attention. Students are terrible about that. And actually, they were really good about like not giggling and stuff at first. But finally, I think maybe they just didn't see it because they were playing games or sleeping or whatever. So then they started noticing, and they were like laughing. It's like, what? It's like they did basically the same thing that just happened. So I'm like, yes, that's a thing. Okay, so tell me, what do we know about chars? Tell me about char primitive types again.
Signed whole number.
Okay, it's a signed whole number. Almost. It's not signed, it's unsigned. Unsigned whole number. Why is it unsigned?
Because there's less memory space. There's more memory space because you don't have to worry about the sign.
Okay, and what with chars, why don't we need negative numbers? How do chars work? What's the purpose of a char?
Unicode.
Yeah, we map to Unicode. So we have this Unicode character set where there is, and how many, extra credit, how many unique characters are in the Unicode character set? 256 is ASCII. How many are in the Unicode character set? 65,536. So it's 0 to 65,535. So that's 65,536 unique characters. Okay, or 2 to the 16th power. That's the number of unique characters. Because it's a 16-bit unsigned integer, which is 2 to the 16th power. That's 0 to 65,535. Everybody remembered that? Memorized? It's in there. Okay. I won't ask you that on a test or something like that to like regurgitate those kind of numbers, but you should know kind of the high level thing that a char primitive type is an unsigned whole number. And why is it a number? Well, because it maps to the characters on the Unicode character set. I think somewhere in that ballpark is acceptable knowledge. Make some sense? Okay, so what are strings? Strings are collections of those guys. All right, now I don't know the official total, what's the longest you can have a string? I'm sure it's a number. It's probably either size of int or size of long. for how long a string can be. Does anybody who's worked with Java before happen to know? Let's Google it. Let's find out. What is max string length Java? I'm going to guess it's size of int, which means that you could have up to 2.1 billion characters. That's my guess.
2 to the 31st.
2 to the 31st? Yeah, so I'm right. Size of int. Does it say that? 2 to the 31st? 2.1 billion. Look at that.
That's also the max.
Oh, you're coming out the actual number? Like, yeah, my precision drops off after the 65,000. You would think it maybe wouldn't, as long as I've been teaching it. Like at some point, like I got the 2.1 billion. Like I've gone as far as that. But yeah, the rest of it. And what's the long is like 16. Isn't it 16 quintillion or something like that? 19? Okay, yeah. I might have known that at some point. Things go downhill real quick when it's bad. You even know, like, look how much more gray I have than even like last year. It's bad.
Is it bad though?
Well, I don't know, maybe. The only thing that might help is maybe weight loss. You don't see a whole lot of like really fat old people. There might be multiple reasons for that. Multiple dynamics that kind of drive that, maybe. What's this? Oh yeah, professors have tons and tons of stress. Yeah, see, it's all compressed, right? So when you go and do a PhD, you have all these years of school. So, you hate school now, right? So imagine going for like some people do their PhDs, it takes like 15 years. You just stay in. Yeah, you're just in. Yeah. Well, that's always a thing. Like, folks, there's so many people that are what's called ABD, all but dissertation. They're still working on their book. And sometimes you just never finish, which is like, oh, you're so close. At that point, it's just a political game. Yeah. And you're going to operate and do a PhD. Here's your... so many people go into PhDs and they have this, oh, I really want to research this. I want to research that. No, you don't. Okay. You can research what you want to research when you get out. If you're going to work on a PhD, what you do is you find one of the professors that you get along with. Your favorite research area is their favorite research area. Okay. So, okay. And then they ask you, well, who do you want to have on your committee? Some people are like, oh, I really want Dr. So-and-so. No, you don't. You want your advisor's best friends on the committee. Okay. That's who you want on the committee. Smooth sailing. Just finish. I had to pay for an extra semester because I finished too quick.
How can you finish it quick?
I did my whole PhD in 2.5 years. The minimum is 3 years. You're paying for 3 years, whether or not you need it or not. I had to give them money to release the. You just got to play the game. And the good news is for all of you. You know what the hardest degree is? The bachelor's.
Really?
Was easily the hardest degree. The easiest was the master's. Because the master's is all in your focus area, right? Mm-hmm. You know, I like computer science. I was good at computer science. All my classes of the master's degree were computer science. Easy. Mm-hmm. You know, I'm not particularly interested in sociology. So, so you have to take. Well, yeah. I mean, I really believe that. So, I mean, I almost think everybody should go on and get a master's anymore, since the bachelor's has kind of become our new high school diploma. Everybody thinks they need to go and get one. So you've already gone through the hell of a bachelor's degree. And that's the worst. Master's is, you can finish a master's in 3 semesters, and it's all classes you're interested in. It's just more money.
Yeah.
But you'll get a lot higher paying jobs. So it'll be worth it in terms of salary for you to just get a master's. PhD, not so much. PhD, you got to want to go into a field where a PhD is needed. You stop at a master's. Most people want to stop at a master's. But most students want to stop after a bachelor's because they're done with school. So I'm just telling you, just suck it up for 3 more semesters or go get a job and do a master's part-time, but don't stop school and say you're going to come back later and finish because you won't. I've been teaching for almost 18 and a half years now. I could probably count on one hand the number of students in that total period of time that have said, I'm gonna go work for a couple of years, then come back and do a master's, and actually came back and did a master's. Yeah, and those students are just ones who got into a job that paid for their master's. So it's like, well, they're paying for it anyway, so I might as well go. Yeah, stay poor for as long as you can. It's a good rule of thumb. We're talking about strings. After the life lesson. Get a master, maybe not as PhD, but stay in school. Masters are easier than bachelors. What's this?
Stay in school, stay poor.
Stay in school, stay poor. I stand by that. Because that's what happens. As soon as you go out and get a job, even if it's not a good paying job by like computer science standards, let's say you're making 40 grand a year. Well, 40 grand a year to a student, that's a lot. It's like, I've been making $9 an hour. And I was the rich one. And now you're making 40 grand a year, you're like happy. Okay? That's like poverty line for computer science. Yeah, you don't want to make 40, you want to make like 80.
Printers at that point?
Huh?
You want to have printers at that point?
Making 40? Well, I don't know. You're just working, you're just entry-level job somewhere. You could always work your way up. That's not saying that you can't get to a higher place, but you probably, with a master's degree, you probably start at 70 with 3 more semesters of work, where the best undergrads are starting at, our top undergrads have been going to Acuity, and they've been starting at like 63, 64. And that's like top in their class, undergrad students coming out of CS. So you're getting an extra 7 grand as a starting point with a master's degree, working at Bob's Garage with a master's degree. And that's less than you would have paid for it over those 3 semesters, or about what you paid for it. And that's where you're starting at, so you'll make it up pretty quickly. And there's tons of online, like our master's program here is 1 night a week for 4 hours, and you take 2 classes a semester. You're done in 3 semesters. So you can still work while you're doing that. There's lots of online ones where you don't even have to go to class at different schools. Find a master's somewhere. I mean, I'd encourage you to come here, but that's just business. So, but plenty of master's programs all over the place that you never even have to like put pants on. You just do it all from at home. So what is it? Stay in school, stay poor, don't wear pants. It's a trifecta. All right. So let's start listing some of our string primitive types here. Actually, we 11:20 is when we're done? Okay, so we'll actually start looking at string methods next time. I want to give you a small assignment. So we're going to say write a method that takes two integers as parameters and returns the larger of the 2 integers. Okay, again, should be a very, 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 very easy assignment, but it'll get you used to writing the function syntax and calling it. So make sure you call and test your method from main. So a function that takes in 2 numbers like 7 and 9, and it returns the larger of the 2 numbers. So in that case, it would return a 9. Okay, a -4 and a 6 would return a 6, so on and so forth. Make sense? Okay, I'll get this up now. Also remember, Bible homework is due on Sunday. I'll get that up now as well. And I will see everybody on Thursday. Note, Typically, Tuesdays is when the student, faculty, staff Bible study is, but this week, because there was a scheduling conflict, it's actually tomorrow. So tomorrow, Bible study from noon to 1. Go to the cafeteria, sign in. It's free lunch, God and grub. Take it down to the terrace room. Yeah, terrace room, and have Bible study. I'll be there. We'll save a seat for you.
They need to rename it
God and grub. Let's talk to Pastor Smith about that. He might be down, but that seems to be a very Littman-esque phrase. Yeah. I'm a fan. But we have to get Pastor Smith's take on that.
I think with a name like that, you might as well just pray before you eat and say, God is